Good evening, everyone. Hellos. Today we'll be doing momentum. It's tricky, but it's nice and interesting. Ritual physical sciences. So the things that are confusing it is just the direction only. Whereby we know what our west is positive, our east. Our west is negative, our east is positive, and then our south is what? Is negative, then our north is positive. But in this topic we'll be using west and east only. Okay, so we'll be just respecting the Cartesian plane. So what is momentum? It is the product of the mass and the velocity of an object. Okay, so the formula, it is P is equals to mv. So you don't have to be stressed about the definition of momentum, because they are saying momentum, it is the product. Remember grade 8, they said the product is what? Multiplication sign. Okay, so momentum is the product of mass and what? Velocity of an object, and then this P is the what? Is the momentum. So P is momentum, m is mass, times is the product, and then v is the velocity. Okay, and then the units for m, which is the mass, it is kg, and then the units for velocity, it is meters per second, not meters per square second. This one is for acceleration, so don't confuse yourself. This one is for per second, or you can write it like this: meters per second. And then p, the units for p, it is kg per meters per second, because it is the units for the mass and the units for the velocity. Okay, so now let's do an example. Okay, example 1. So check this example now. They're saying an athlete of mass 70 kg runs at the velocity of 45 what? Kilometer per hour. Determine the momentum. So P is equals to mv. What is our mass? 70. What is our velocity? Someone will say 45, but remember, what did we say? We said velocity is measured in meters per second. So what do you do when you have kilometers per second? You simply say 45, you divide 45 by 3.6, and then you'll get let me check, you'll get 12.5, which is meters per second. So when you convert kilometers per hour to meters per second, you divide that value by 3.6. okay, and then, or you can say 45 times 5/18, you'll get the same answer. So now we have our 12.5, and then when we punch it in our calculator, it gets 875 kg meters per second. You see? So that's how you do it. If they gave you the mass, if maybe they want the mass, you simply say what? M times maybe the velocity is 4, and then the momentum is 10. What do? You say 4m, then 10, then 4, then 4, then you get your mass. If they want the momentum, you do it P is equals to mv, and then if the velocity is meters per second, you've just put it, you don't need to convert it, then you're fine. So that's how we do the momentum. It's just simple. Some tricky parts are the linear conservation law of what. So now let's do the change in momentum. So now let's do the change in momentum. A change in momentum is written like this. It is just delta p. So this delta means you go to the momentum can change. Okay, so the change in momentum, it is delta p. Change in momentum is initial momentum, final momentum minus initial momentum. Remember what the p is for the momentum, and then these are the initial and final. Okay, so let's continue. Don't forget, Uti, I said momentum is what? P is equals to mv. So where there is P, I will put what? mv times f, and then minus mv times I. So when you're gonna write it, it will be what? mvf minus mvi. Pele, we are substituting. This p on its own is equals to mv. So where there is p, I put mv, then I multiply by the f. And then if it is like this, I can factor out m. So it will be mvf minus vi. Then you get your change in momentum. You can use both. It depends. These are the same thing. This is the same thing, okay? Because if it is 2020, this is the same mass, so you don't have to be confused. So let's check an example. Actually, I'm lazy to write it. So it's saying a cricket ball, after being bowled to the air with a momentum of 7 kg meters per second. So our momentum there is 7 kg, okay? And then to the east, so let's write east, which is what? Positive. And then it hits the headsman in the opposite direction, and so that the ball's momentum changes to kg to 10 kg. So initially the momentum was 7 and it, so after then it was now 10 kg. So now they want the change in momentum. What are you gonna do? You're gonna write the formula. Delta p is equals to pf minus pi. Then our pf is what? Minus 10, because they said in the opposite direction, so it must be negative. You understand? Because it was going to the east and then it was in the opposite direction. So when it is like this, note this is negative, and note it is also facing to the west, and then it's going to be minus 7, and then it's going to be what? Negative 10 minus 7 is negative 17 kg, then meters per second. So guys, you got it. Okay, so if they're saying draw a vector diagram for that pi, pf, and delta p, you simply do what? It's angitibate, it was 7 kg to the east, and so you just say this and then write your pi and then say 7 kg meters per second, and then 10 kg to the opposite direction. So it's going to be like this, then pf, and then 10 kg ms negative 1, and then the change in momentum is what? We got negative 17, so it will be like this, p delta p, and then negative 17 kg m negative 1, just like that. Okay, so let's continue. Right now I want you to introduce you to the Newton's laws in terms of momentum. So let's go. Newton's laws in terms of momentum. I'm lazy, it's fine here. And then now let's continue. You know what, in the Newton's laws we have this F net is equals to ma, but what do we know about this special acceleration? So you're gonna do this, but acceleration is equals to vf minus vi over delta t. Okay, like I'm trying to show you the theorem for getting the f net in momentum, not using this one. Okay, and then it will be therefore f net is equals to m, where there is a, I put what? Vf minus vi over delta t, and then I'm gonna continue doing what? F net is equals to mvf minus mvi over delta t. Remember, mvf minus mvi is what? Delta p. It represents delta p. Okay, just figure the man. Then I'm gonna say f net is equals to delta p over delta t. We are now done with our theorem. We have proved it. Okay, so that's what you must know. F net is equals to ma. So Newton's laws in terms of momentum. How do you prove that? We are gonna say F net is equals to ma according to Newton's laws, but acceleration, from grade 10 knowledge, acceleration is equals to Vf minus Vi over delta t. Then where there is acceleration, we put what? Vf minus Vi over delta t. So it will be F net is equals to m Vi minus Vi, Vf minus Vi over delta t. And then it will be F net is equals to mVf minus mVi over t. And then since you are now having mVf minus mvi, we are already seeing what we are now representing delta p, which is the change in momentum. Then our F net is now gonna be delta p over delta t. We are using this thing so that if maybe they are saying if the change in momentum, maybe if there's if p is equals to some maybe 10 and then t is equals to 5, get your F net, you use the formula and done. You see. So thank you guys. I will send, I'll do a impulse, we'll do impulse soon. I'll send a video on impulse. Thank you for guys, thank you very much. I hope you enjoy.